Hey everyone, sorry if it's super echoey or if you can hear music, because I'm at the Hard Rock Hotel in San Diego and it's loud. And anyway, today you're talking about writing and expanding multiplication expressions, or we're just kind of combining similar parts of expressions and writing equivalent expressions. So, you can see in this first part we're going to be taking longer expressions and simplifying them, and then we're going to actually think about what those would look like, what expressions that are all combined would look like if you could break them apart. And then I'm going to tell you how to play bingo. So let's just get started. So this first problem, diagonal. In this first problem, it wants us to write each expression using the fewest number of symbols and characters, use math terms to describe them and the parts. So this first one, we have 6 times b, and so hopefully we all know how to do this already. We don't need the multiplication symbol there. That's the same thing as 6b. Because 6b is, we could say that 6 is the coefficient. Sorry, I forgot my pen, so I'm doing all this with my finger. And b is the variable. I probably won't write all these out because it's going to take forever. But so b, next example. B, now what you should notice with b is, you don't want to treat it the same as a and just do 4, 3. We don't want to write that like this, and say that that's the same thing as 4 times 3 times h, because that looks like 43h. That is 43h, so this doesn't work at all. What you need to do, though, is you can think, well, can't you just multiply 4 times 3? Well, yeah. So we can just multiply 4 times 3. 4 times 3 that would be the same thing as 12 times h, and we can simplify that to 12h. So 12 is the coefficient. I'm just going to simplify it. H is the variable. Now this next one is same thing as before. We just have 2 times 2 times 2. Well, those are all numbers. I can actually multiply those things together. So I can just 2 times 2 times 2 is 4. 4 times 2 is 8. So this is the same as 8 times a times b. Now a and b are different variables. We don't know what a is. We also don't know what b stands for. So you can't actually combine those into anything like we can all those 2's. So now all that's really left that we can do is just get rid of those multiplication symbols and just write 8a b. So whenever you have letters next to each other like that, it still just means to multiply. So in this case, 8 is the coefficient, and a and b are variables. For this next one, now you might think, well, I can't really combine these things because the 5 isn't next to the 3, but you can remember that the order of multiplication doesn't matter. So you could think, well, this is the same thing as 5 times 3 times m times p, because we can just flop around the order. It's all multiplication, doesn't matter. And that's the same as 15, 3 times 5, or 5 times 3 is 15, and then we just have that m and the p, so this would be 15 m p, whereas 15 is the coefficient, m and p are the variables. And the last one, they're trying to be a little bit tricky here, and you might think, well, it's 1, so I'm going to write this as 1gw, but you actually don't need a 1 there. You can just write it as gw. And the reason is, it's some of you have been doing this, before. It's, if you're trying to point across if you're at recess and you're trying to point someone out to a yard duty, you're not going to say, hey, that one boy over there, or hey, that one girl. You don't need to say one in front of it. You're just going to say, hey, that boy, that girl. So you don't need to put ones in front of variables if there's only one of them, because you should just think that 1 times g is going to be the same thing as g, right? Because anything times 1 is itself. So that 1 won't change anything. So we actually don't need it at all. We're going out of order. Okay, whatever. Example 2. So this is when we have simplified expressions and we want to expand them. Sometimes you want to expand expressions because they might be too simplified, and we'll see this later, so we're thinking ahead. But sometimes you want to break things up into smaller pieces because it's easier to work with them as smaller pieces instead of as a huge chunk. So this is basically the opposite. So 5g, that's the same thing as 5 times g, right? 7abc means that's the same thing as 7 times a times b times c. 12g is the same thing as 12 times g. You could also actually even break that up more if you wanted to. Other examples would be, you could say, well, like 2 times 2 times 3 times g, that would work. Or you could say, 2 times 6 times g. Those would all be equivalent expressions because they're all times g, and if you took all those numbers, 2 times, with this one, 2 times 2 is 4, times 3 is 12, 2 times 6 is 12. So they all get you back to the same place. So there's a few different ways you can break them up. They just have to, if you put them back together, they'd still have to get to 12g. This one could be 3 times h times 8. Just breaking them up. This next one could be 7 times g times 9 times h. Or, they might break it up more, and they might say, well, I want to break it down into the smallest pieces. A lot of times, if you were going to break it up smaller, you want it to be in its smallest pieces. So for these last two, how small can you get 8? Well, I could say 3 times h times 2 times 2 times 2. Or with the 7 times g times 9 times h, I could say 7 times g times 3 times h. And if you're wondering how I got the 2 times 2 times 2 and the 3 times 3, this part right here and this part right here, where I took this 8 and this 9 and broke those up, those are their prime factorizations. And a lot of times we use the prime factorizations to break it up. So, 8 is 2 times 4, and 4 is 2 times 2. So we have, sorry, that doesn't even look like a 2. So 2 times 2 times 2, that's how I broke those up. The last example would be find the product of 4f times 7g. So this is the same thing as before, just word problems. So this is, and you might think, oh shoot, it's like kind of combined and kind of not combined. Well, but you can break up these individual pieces. 4f, this is 4 times f, and that's times 7 times g. Well, okay, that's just going to be 4 times 7 is 28, and f times g, f, g. We don't need any multiplication symbols. So they can be combined because you can think of, you can break the whole thing up like this too. So when I'm looking at this, it's all multiplication, and there's no symbols here, and there's no symbols here, and there is a symbol here, but everything's just being multiplied together. So I can multiply, I know I can multiply the 3 times the 9, so that could be 27. And the letters I can't multiply together, I don't know what they stand for, so I just D, E, Y, Z. So that means 27 times D times E times Y times Z. And this last one's a little bit more tricky because it says double the product of 6y and 3bc. So we actually have to figure out what the product of 6y and 3bc is, but it wants us to double that. Well, I could write that as an expression first. So double means times 2, 2 of them. So 2 and then I'm going to be fancy and write it like this. I know I have 6y times 3bc, right? This just means I kind of wrote it doing order of operations, so we can do all this multiplication first, find that product, and then double it. So 6 times 3, that would be 18, so I'll rewrite that over here. I ran out of space, so I'm going to write it sideways instead of down. That would be 18 YBC, and then this is just 2 times 18 YBC. Same as before, you can't multiply, you can multiply the 2 and the 18, but you know the letters you can't do anything with. This is the same as 2 times 18 times Y times B times C, right? So it's going to be 36 YBC. Cool. All right, back to, so I went back to this slide. So what we have here is, this is a bingo sheet. There are 3 versions of these. They're in a stack. They're under where the exit tickets normally are. And you have some empty spaces right here. And they're in different spots in all of your things. And you have these different answers and they're scrambled. Just grab one of the pages. There is a full page that has been typed up for you with some answers, some extra bingo answers. You're going to take those answers, I think there's just enough to fill in the spots, maybe one more, and you're just going to write them wherever you want in any order in all of your empty spots. And once you do that, there should be a stack of clipped together cards, and the cards will have the an equivalent expression that's different. So, for example, let's say we have this one up here. This is, I think, is an easy one. This one you might flip the card over and it says 10M. Well, you're going to look for on here what's equivalent to 10M to mark off that spot. And you're going to be looking around at 10M. You should be able to figure out is the same as 2 times 5 is 10. This is 10M too. So you could mark it off. I'd probably use, if you want to play more than once, maybe like mark X's in the corner. And then you can play once and then, you know, if you don't want to erase it. But there you go. That's basically what you guys are doing in the green tables. Have fun.